Suppose you have data of students that studied for certain number of hours and also their pass or fail status. This right here. So this student, he studied for 1 hour. His status is 0. 0 means he failed. This student studied for 2.5 hours. He failed. 3 hours, failed. 4.5 hours, he passed. 5 hours, passed. 6 hours, passed. Design a machine learning model that can determine a pass or fail status of a student based on their score. Let's say somebody's score is 3.4 and you want to determine whether this individual, the student who scored 3.4, you want to determine his pass or fail status. These types of problems are done by using logistic regression for binomial classification. So in this session, we are going to be focusing on these types of problems. Now, this problem can be easily solved using Python's scikit-learn package. So here I'm importing my logistic regression, importing my NumPy, creating my data right here. These are my data for 1, 2.5, 3, 4.5, 5, and 6. That's what this data is right here. These are the corresponding pass or fail status. So 0, 0, 0, 1, 1, 1. So I write 0, 0, 0, 1, 1, 1 over here. Then I call my model over here. I train my model. And then I give a sample value, 3.4. And I ask, predict me the probability of this guy passing when his score is 3.4. And then I print my probability right here. And it prints out the probability of passing is 0.41. So this is how it's done in scikit-learn package. Now I'm going to explain you the theory, the math that is happening behind the scene. So sometimes we have to predict whether a data point belongs to a certain category. We are not predicting a numerical value of a data, we are predicting the category. Now, category can be a numerical value. It could be 0, 1, or 1 and 2, but it cannot take infinite range. It's always going to be finite. Okay, so a category can be binomial, it can be multinomial. A binomial has only two possible classes. In other words, there are only two possible choices. For example, a customer, whether he's going to buy or not buy a product. A student, is he going to pass or fail? An email, is it a spam or not a spam? A patient, does he have a cancer or not a cancer? These are all your binary choices. So this is binomial. A multinomial, on the other hand, there can be three or more possible types of category. For example, if you give an image can be of a cat, dog, or a sheep. Iris data set, a famous data set. So in this case, your flower, it can be setosa, it can be versicolor, or it can be virginica. So we need a model that can classify points based on your data and can classify what category it falls under. This is where your logistic regression comes. And so logistic regression is a model that predicts the probability. It predicts a probability, and probability is always going to be between 0 and 1. And then we apply a rule. And generally, the rule is that if your probability is more than zero point 0.5, in other words, is more than 50%, then we are going to predict that that particular data belongs to one of the class. Now, in order to perform binomial classification, we use a function. It is called a sigmoid function. And this is how it looks like. In this case, this is 1 divided by 1 plus e to the power minus z. Your e is Euler number, 2.71828. It's an irrational number. And what this sigma does, it maps any z value to a value between 0 and 1. So this is the graphical representation. This is the graph of the sigma z. So you can see that your sigma is going to be between 0 and 1. It will never exceed these values. It's always going to be in between. And your z can take any value from minus infinity to plus infinity. And generally, we use this in logistic regression to convert a score, a linear score z, into probability of obtaining a z value. And this way we can classify what point a data belongs to. So let's take a look at an example. Let's say you have a data and the z value of the data is z equal to 2. We did some calculation and let's say it comes out to be z equal to 2. That would be right here. And let's calculate the probability of this. So this one, if you go on top right here, it's going to be somewhere over here. So we calculate the probability over here using my expression for sigma z. So I substitute my value. This is going to be 1 divided by 1 plus e to the power minus 2. Now remember, your e is Euler number. Substituting your value in there, this will come out to be this number. Solving it further, your answer is 0.8808. So this number right here, it comes out to be 0.8808 approximately. So that means your chance of obtaining z equal to 2 is 88% chance. 88% chance. Now let's look at the general workflow of how you calculate the probability. You start with your input feature x. Okay, that's your step one. First, you calculate a linear score in our case. In my case, my linear score, in this case, by the way, x is a study hours in our present case. So you calculate your linear score, and the formula for linear score is this: z equal to b0 plus b1 times x. My b0 and b1, these are called bias and weight, and they are calculated during the training from your data. That's your step one. Step two, once you have found your z value, then you find its corresponding sigma value. And then you apply sigmoid function over here. So this converts your z into a probability. So this will give you your output, and the output would be between 0 and 1. So this gives you the output that represents the probability of you getting exactly equal to 1. In other words, the probability that your z falls in the class 1. In this case, my class 1 was pass. Now, if your probability of pass, if this number comes out to be greater than 0.5, then you are going to predict that it belongs to class 1. In other words, he's going to pass. If the probability is less than 0.5, then you're going to predict that he falls in a class 0, which means fail. So now let's try to understand that process using an example. So assuming that from the training data, we have calculated our bias B0 as this value right here, and your weight B1 is calculated to be this value. These two values are calculated during the training for you, by the way, and we want to find whether the student who scored 3.4, did he pass or fail? Well, let's do this thing step by step following the same process. First, you convert your X. In this case, X is your study hours, convert into Z score. Another word for that is a linear score. So I use my formula. I'm actually using this right here. Okay, I plug in my values. B0, B1 study hours is 3.4. Plug in all the numbers, and your answer is minus 0.372. So this was your step one. Step two, now you apply your sigmoid function. I'm doing this step right now. So it converts this is my sigmoid function. It converts this number into a probability. Apply my formula over here, and the answer comes out to be 0.41, 41%. This is the probability of the student being on class 1, category 1. In other words, this is the probability that he's going to pass the exam. Now here, the probability of class 1 is less than 0.5. In other words, he's not going to pass, he's going to fail. That is the probability of this student. Now, some of you must be wondering, how did it calculate the value of B0, B1? Well, there's a little bit of math happening behind the scene. Most of the math is taken care for you by these programs. So in this particular instance, right here, I'm actually feeding my data right here, training my model. And when I train my model over here, this is where your B0 and B1 is found by your program. And then I'm making a prediction and then printing my result. Now, if you want to print out the value of your B0, B1, you can do that too. And this is exactly what I'm doing in the next line right here. So I'm printing my value of B0. I'm printing my value of B1. Let's come down here. I'm printing my value of B0 and B1. I'm actually reading my B0 over here, reading my B1, and I'm printing these values. This is how I actually got that number from here. So to recap, this is the general workflow of logistic regression. This is your machine learning model before it's trained. It does not know its B0, it does not know B1 value. You feed the training data into that. It learns B0 and B1. It calculates the B0 and B1 from your training data. Then you feed a test data set, X equal to 3.4. This is a student who studied for 3.4 hours. And then this machine learning model is going to predict the probability of this person whether he's going to pass and fail. So in this case, the answer comes out to be 0.41. In other words, 41% chance. So in the previous case, we studied with a scenario, there is only one feature, study hours. What if you have many features? Let's say study hours, how many hours a person slept before the exam, what was his previous score? You can have many features over here. So when you have many features, you write your X as study hours, comma, sleep time, comma, previous score. In this case, I'm just assuming there's only three of them. So here, my logistic model is going to produce a number, a probability, and that probability is going to the probability of your y equal to 1. That's what it tells you, that the output is going to belong to this class. That's what the probability represents. So we're going to follow the same step. Step 1, for your many features, you compute this value, z. In this case, my b0, b1, b2, b3, these are my b0 is my weight, and b1 to bn, these are called my weights right here. Now, these are calculated during the training time from the training data. Your x1, x2, x3, these ones, they represent your feature. In our case, my x1, x2, x3 would be this one. This will be my x1, this will be my x2, and this would be my x3. So this is my step 1. Step 2, after you have calculated your z value from this b0, b1, x1, b2, x2, b3, x3, all these values, then you apply your sigmoid function. Convert your z into probability. Use the same formula. And then if your probability of is greater than 0.5, then you're going to predict it belongs to class 1. Otherwise, if your probability is less than 0.5, then you're going to predict it's class 0. So now suppose we have this data right here, x1, x2, x3. This is my feature right here. And this is my target. In this case, it represents maybe the student passed or failed, 1, 0, 1, 0. Okay. And in this case, you can see my feature has there are three different features over here, x1, x2, x3. This could represent anything. This could be the number of hours he studied, how much time he slept, any number. And based on this, you're making a prediction of this right here. So the way you do is you actually import all your libraries just the way it is. Then this is my x right here. So this right here represents my x. This would be my x right here. And then these my corresponding y, which would be this right here for each one of these points. So I have 1, 2, 3, 4, 5, 6 points. You're going to find 6 of them over here. I call my logistic regression model. I train it, and then I pass the test data. So in this case, I'm specifying a value 3 and 1.5 and 0.7. And I'm trying to make a prediction on these three numbers, or what would be my output. Well, it comes out to be 0.90. In other words, the probability that this point belongs to class 1, it belongs to class 1, its probability is 0.90%. In other words, is 90% chance this point belongs to class 1. So this point belongs to class 1.